Okay, thank you. I appreciate the invitation to be here today and to talk about some research that we have done at WebAIM and what it might mean for web accessibility. So I'm Jared Smith. I'm the Associate Director of WebAIM. WebAIM is short for Web Accessibility in Mind. We are a small nonprofit consultancy based at the Center for Persons with Disabilities at Utah State University. And we do web accessibility. We provide training and consultation, website evaluations, and we have our website, webaim.org, has a wealth of information and resources that might be of help to you. So I'm gonna need to do a little adjustments here. Hold on a second. All right, I'm not sure what this pop-up is. Sorry, folks. Okay, there we go. So I'm going to talk about the WebAIM Million and accessibility data. First of all, there really is a shortage of good accessibility data that is out there. There certainly are accessibility studies and research, but many of those are published behind paywalls. There's a lot that's happening that's more smaller scale, but isn't a lot of sharing out there, I think, when it comes to accessibility. Certainly not as much as there probably could or should be. There's a quote that I like about data, and it's, if we have data, let's look at data. If all we have is opinion, let's go with mine. And very often that's how it works with accessibility. Um, we we all have opinions. Some of that is backed up with data, but very often it's not substantive data. It's not comprehensive, and very much it's opinion, and everybody prefers their own opinion. And so the WebAIM Million research was an attempt to at least address part of that, to give a bit of a snapshot of accessibility on the web, to see where we are at and where we're going, and hopefully help to influence and guide some changes. So the WebAIM Million was an analysis of the 1 million, well, the homepages for the 1 million top websites. So we did our initial analysis in February of 2019, and then a follow-up a year later. We did a little mini analysis in August at the 6-month point, but we're focusing really on the annual testing. This year, we also tested 100,000 interior pages from the top 1,300 sites. So we collected up to a few hundred randomly collected pages within those top sites. Now, some people ask about what is top sites. We used a few different sources to determine the most commonly accessed and visited and referenced websites. So our research was not to define the top million websites, it was to get a lot of accessibility data. Um, some people also ask about why just home pages for our primary study. First of all, it's the gateway for most people. It's the first thing that they see on most sites. We also know that there's a strong correlation between the accessibility of home pages and the accessibility on other pages. And that's part of why we also collected these 100,000, 130,000 some odd interior page accessibility data this year, is to do more of that type of analysis between home pages and those interior pages. Short version is we didn't see a whole lot of difference between those. The data is collected via the WAVE standalone API. So WAVE is a popular accessibility testing tool. We have free versions that are online. We have Firefox and Chrome extensions that you're welcome to use and try if you're not familiar with those. They help test and help facilitate human evaluation. But this is an automated process. So we have an internal API that was used to analyze these pages, render them within a browser, perform this robust testing. But automated testing is always limited. So we just have to keep that in mind. We're really looking at a small subset of the overall potential accessibility issues that users with disabilities might face. We also detected with certain types of technologies, about 1,200 different technologies, and whether those technologies were in use on those sites. Things like WordPress and PHP and Angular and jQuery and things like that, as to whether they were in use on these pages. We also this year collected some category data what is the content of these pages and sites, so that we could do some comparisons across categories for accessibility. And so over our 2 years, we have an awful lot of data about technology and accessibility for these million homepages and 100 and some odd thousand interior pages. So I don't, we talk about big data. I don't know if this is big data, but it won't open in Excel. I know that. it's an awful lot, and there's a lot more analysis that could be done on these data that we've collected. So what did we find? Across the million pages, this is a primarily focusing on this year's analysis. This year we detected about 61 million errors. Now, errors are barriers for end users with disabilities. They are things that with a high level of reliability, we know are going to negatively impact users, and that align with failures of Section 508 and the Web Content Accessibility Guidelines. So there certainly is a possibility for some false errors in there, but we absolutely try to minimize those. These are things that have a high reliability of negatively impacting users. So that's about 61 errors per homepage. So consider that somebody with a disability on average would expect to encounter 61 instances of something that could pose a barrier or difficulty for them on the average homepage. This is an increase from last year's analysis, a 2.1% increase in number of detected errors. That comes out to about 1 in every 14 page elements that has a detectable error. So 1 in every div, span, paragraph, image, form input, whatever it might be on that page, 1 in 14 on average will have a detectable error. As we align those errors with the Web Content Accessibility Guidelines, 98.1% of pages had a detectable WCAG to failure, and that's up from 97.8 last year. Now, remember, this is a subset of potential failures, so that would suggest that the actual conformance rate with those guidelines is very, very low. I would think probably much, well under 1% for the actual conformance rate with WCAG level A and AA. One of the more interesting things that we found this year was that the number of page elements, so page elements are rendered DOM elements, div, spans, paragraphs, forms, section elements, things like that. The number of page elements increased over 10% in a year. To me, that's huge. That's a big increase in page complexity and weight and the number of elements to an average of 864 elements on the average homepage as of February of this year. When we look at those interior pages for the top 1,300 websites, these numbers are pretty similar. The error rates, the WCAG failure rates, the complexity, they're pretty comparable. So there's not it was just kind of interesting. So what that means is there's in general not a real big difference in accessibility between homepages and the interior pages. As we look at the type of issues, I will just pause it while I think of this. If there are questions along the way, you can post those into the chat window. I'll try to monitor those, and if I can't keep up, I may hold those to the end, but you're welcome to post questions along the way in the chat window. So as we look at the type of issues that we found, these are the number of pages within the million-page sample that have these particular types of errors. So 86% of pages had low contrast text. So that's text where the contrast between the foreground and the background does not meet the WCAG 2.0 level AA contrast requirements. This is by far the most prevalent failure that we detected. 66% of pages had images with missing alternative text. 60% had empty links. So it would be a link, very often like an icon or graphic, usually a CSS graphic, where if, say, a screen reader user were to navigate to that link, there's no text within that link or alternative text to be presented. So a screen reader user would just hear linked without any description or context. 54% of pages had missing labels for form inputs, so no associated text or description for form inputs. 29% had empty buttons, similar to empty links. It's a button that does not convey any content. And then 28% of pages had missing document language. Very important for multilingual screen reader users. It ensures that that page is read in the appropriate language. Now, these are all really accessibility 101 errors. They're all things that are found in pretty standard basic HTML. They're all readily detectable. We were able to detect those using a basic automated process. And most of these are pretty easy to fix in almost all instances. So while this is a little dismaying that there's such a prevalence of issues that are out there, one thing that does give me hope is that if we just focused on these 6 types of errors and were to address those, this would have a huge, significant impact on the experiences of users with disabilities in accessing web content. So, it's kind of interesting that these errors constitute the bulk of the issues, at least the detectable issues that are out there. Yet we very often spend the majority of our accessibility capital and bandwidth on the fringes, on ARIA widgets and web components and things like that. And that's not to suggest that those things aren't important, but these are the things that are typically most impactful, most prevalent, and addressing these few things would have the biggest impact. So maybe we need to go back to the basics a little bit. Judy asked the question, does the scan see empty alt text as missing alt text? No. We have logic. Yeah, alt equals pro absolutely would be correct for decorative images. Yeah, the missing alt text does not count alt equals pro, except in instances where it's a linked image. If an image is the only thing inside the image and has alt equals pro, that would be an error, because that image must have alternative text. There's a lot of complex logic in there. But yeah, we ensure that these errors again are highly reliable actual errors. Gary asked the question, are you strictly focusing on HTML content and errors, or will you also address files posted to or shared on web pages such as PDF, Word videos? This is only on HTML content, the focus right now. In the future, we may extend that to other documents, things like that, but this analysis really was just on the web pages and HTML content. Good questions. Thank you. So a little more detail on what we found. On average, there were 36 instances of low contrast text per homepage. So 36, paragraphs. These aren't words or characters. These are elements that have low contrast text per average on homepages. About half of images had missing or questionable or redundant alternative text. So alternative text of image or something like that was clearly wrong, or maybe an image file name, or redundant alternative text, meaning 2 images or an image and adjacent text are exactly the same. So a screen reader user would hear that twice. Over half of the 3.5 million form inputs that we analyzed were not properly labeled. We also looked at the usage of ARIA, Accessible Rich Internet Applications. If you're not familiar with it, don't worry too much about it. It's a way to extend the accessibility of HTML, primarily for screen reader users, just by adding some additional markup into your existing HTML page. But we did find that even though the intent of ARIA is to enhance accessibility, we did find the pages that had ARIA had on average 26.2 more detectable errors than pages that did not have any ARIA present. And the more ARIA code that was in a page, the more detectable errors. Now that's not entirely unexpected, because pages with ARIA tend to be more complex, thus the need for the ARIA to enhance that accessibility, because standard HTML may not be sufficient. But this is a little concerning, that ARIA does not correspond with fewer accessibility errors. It corresponds with more, in fact, much more. And a lot of that is because of misuse of that ARIA markup. It's not being used correctly. As an example, is we analyzed implementation of ARIA menu markup, which is used to enhance complex menus within a web page or web application. Over half of those that we analyzed were not properly coded. So they're not actually providing better accessibility, and in fact, could be providing much, much worse accessibility because that code has not been properly implemented. So A few other things that we found. 24% of pages had links with ambiguous text, so links like click here, more, continue, which could be a little bit difficult. 11% of pages had a skip link, which is really helpful for users with motor disabilities, maybe that can't use a mouse and maybe interacting with the keyboard, as well as screen reader users that very often use the keyboard. But 11% of those links were broken, meaning that the link actually didn't function in skipping over navigation or skipping to the main content. There was a question about reviewing the top government sites. I'm going to kind of get to that in just a little bit, and some of the differences with government. 12% of home pages had no headings at all, so not a single heading, and 39% of pages had skipped heading levels. We also found the pages that had a valid HTML5 doc type, which would generally suggest that the page is probably newer, or at least using a framework that provides a newer code. That those pages had 46% more elements than those with other or probably older doc types, and they also had 21% more errors than other pages. So this might suggest that newer pages, not only is the overall rate of errors increasing, but newer, more recently updated pages can have a lot more errors than older pages. That's a very concerning trend. As we look at categories of these home pages, there was a lot of disparity between certain categories of sites. For instance, news and weather pages had on average 85% more errors than the average homepage. So a lot, I mean, almost double the number of errors on news and weather pages. A little interesting, maybe concerning, especially in the age of COVID-19, where we're all trying to get accurate and relevant and important news and information. The accessibility of those sites on generally was much worse than the average. Shopping sites had 49% more errors than average. Art sites 21% more. Travel 12% more. And these are just a few of the categories that we analyzed. There were 30 or 40 different categories. These are all available on our online WebAIM Million report. As we look at but there were some categories that had better accessibility. Education websites, for example, had 5% fewer errors than the average. Now, that's certainly better. I would expect that education websites would have a lot fewer than just 5% fewer errors than the average page. Health websites, 8% fewer. Career websites, 9% fewer. Homepages, 12% fewer. And then government, which is the primary focus here, 16% fewer errors than the average, which puts the .gov really is the best category of all of the different categories that we were able to align these homepages to. So kudos to all of you. There were definitely very notable differences in .gov, .us, and .edu websites that align with US websites were among the very best category and top-level domain websites that we analyzed. So that's great. I think that shows that there's something good. There definitely is something positive and good that's happening in government, and that can perhaps serve as a model for others. Now, even though government websites fared the best, they still had, I think, 42, right? I don't have the number. I should put it in my notes. No, I'm sorry, it's right here. It's 27 errors per page on average. So 27 instances of potential barriers on the average .gov website. So there's still quite a few barriers that are out there, but much better than the average. So thank you for the work that you're doing. Let's continue that. And not only continue it, but maybe extend that work and those efforts elsewhere so that we're bringing that average across the web down. We also analyzed different types of technologies. This is I just pulled out a few of these to kind of show some of the differences. So if a technology is present on a website, a home page, then we looked at the difference in the average number of errors. So lazy.js, which is a JavaScript framework, for instance, had 200% more errors, 3 times the number of errors of the average home page when that particular framework was in place on a web page. Drupal ads had 61% more errors, 98 errors per page on average, if that homepage had at least one Drupal ad. Of interest is the errors were not introduced by the Drupal ads. There's something about the nature of those pages that is causing them to have more errors. So it's kind of interesting, just the nature of pages that would present a Drupal ad are much more likely to have detectable accessibility errors. Bootstrap, which is very popular, had 9% more errors than the average homepage. jQuery had 7% more. I want to focus on jQuery a minute because it was present on almost 80% of the homepages. In fact, the jQuery, the presence of jQuery corresponded to almost half of the total errors that we detected, those 61 million. About half of those were on pages that had jQuery present. Now, we're not saying that jQuery caused those errors. Or correlation does not mean causation. We don't know that. But when jQuery is present, there's quite a few more errors, and there's quite a few more errors across 80% of the web. That's huge. That's really impactful. Is there maybe something that could be done to impact that and change that a little bit? React had 6%. The React framework had 6% more errors than the average page. Now, React is sometimes the whipping boy of accessibility, and it did correspond with more errors, but not a lot more than the average. WordPress was at 1% more. So not a big difference, but WordPress was very prevalent, very common among sites. Imagine if there were things in WordPress that would cause that number to go down. That could have a really big impact across the billions, with a B, websites out there that run on WordPress. Drupal, 8% fewer errors. Joomla, 16% fewer errors. And then Gatsby, this is one we didn't report on our website because it was not as common. We only focused on technologies that were present on at least 5,000 homepages out of our million. But Gatsby is a JavaScript framework based on React, very complex, very robust, but corresponded with 43% fewer errors than the average homepage. In fact, it aligned with the fewest number of errors of all technologies that we analyzed. To me, that tells me that there are models out there. Somebody's doing something right at Gatsby, and I know who they are, and they're doing amazing work, but the technologies can make a difference. And I think Gatsby shows this. It proves that technologies can build a culture of accessibility. They can provide education resources. They can help reinforce and maybe even enforce accessibility in ways that can be very impactful. So hopefully these data can be maybe a little transformative. I think this provides us some models for good and bad that maybe we can start to look at and influence and start to make some changes with. You can, in our million-page report, it's fully online. You can get lots of data that's out there. We also have a lookup function, so you can put in any homepage domain, and it'll tell you how that particular page aligns with our overall sample. So the results for GSA.gov, wonderful. Top 5% of homepages, 0 detectable errors. Yay, that's great. We also show the previous rankings from last year. And so GSA.gov went from pretty much middle of the pack to top, about 1.5% of pages. And we use some interesting metrics to determine that ranking, but 0 detectable errors. That's wonderful. It shows progress, and hopefully these data are starting to influence some of those types of changes. So as we look at overall trends, a few things. We see some small increases in the number of errors, small increases in the WCAG and Section 508 failure rates, at least over the course of the last year. Significant increases in page size and complexity, and a pretty big increase in the usage of ARIA across those pages. And again, ARIA also corresponds with an increase in detectable accessibility errors. So, so what does this mean for the future? There's a XKCD comic here that has this newlywed couple, and the husband has charted the number of husbands that his wife has, and it goes from 0 yesterday to 1 today, and he projects this this linear growth out, and he says, you know, as you can see, by late next month, you'll have over 4 dozen husbands. The wife says, hold on, shouldn't you be using more than 2 data points? And so he does. So he plots out like multiple days of 0 husbands, and then, you know, today 1 husband, and the line skyrockets to infinity. And he says, you know, oops, you're right. So in short, I don't know what this means. I don't know what it means for the future. It's hard to project from the data that we have. We are seeing some trends we're going to continue to analyze into the future, but I don't know. It's a little bit hard to know. But it is concerning. You know, our reports have caused a lot of dialogue and question about accessibility. This is a quote that just hit me so strongly when I first read it. It's by Winston Hearn, and he wrote, "The web industry has collectively exercised its power to state that disabled people do not belong here." Other blog posts written about this. One was called "Fighting Uphill." One was called "The Web We Lost." I don't know. I want to be positive about some of this, but it is certainly concerning the prevalence of accessibility issues that are out there and the great barriers that these are posing to individuals with disabilities. So I hope that this can continue the dialogue a little bit. So what do we want to do moving forward? What are some future possibilities? Well, we're going to do an annual reanalysis of these pages, and maybe it's DINA. Maybe in the future it'll be the WebAIM Billion. I don't know. We want to get more data so that we have a good sense of where we're at and what the trends have been, and maybe where we're going. Maybe we can define metrics for better weighting of errors to better determine the end user impact. You know, how impactful are these issues that are being that are present out there on the web? What's the impact on the end user? That gets a little bit tricky. You know, are missing captions more important than missing alternative text? You know, do you favor users with auditory disabilities over those with visual disabilities? I don't know, it gets a little tricky, but I think that could help us know what the impact is, not just that there is a bunch of impact that's out there. Maybe deeper data analytics. If you would like to help us analyze these data that we have, we'd love to get additional eyeballs on it, looking at it. Maybe manual testing data to maybe correspond automatically detectable issues with manually detectable issues. So we know, you know, if these detectable issues are present, maybe these other types of issues are also present. If we can define those correlations, I think that can help us extend beyond just fixing the automatically detectable issues, which are just a small portion of the ones that are out there. And then better models for what's working. We need to share success stories. We need to intervene. We need to fix these failures when they're detected. I'm also excited about the prospects of machine learning and artificial intelligence. You know, we all know about just the amazing potential for this. And I think there's a lot that can be done in accessibility and with data sets like we have and that others have to help us effect change. You know, when we talk about machine learning and models, one thing that's a little tricky is the difference or delta between the good models that we have and the bad models. It's huge. It's significant. You know, the average number of errors was 61 per page, but some pages had tens of thousands of errors. Some had 0, and it's really hard sometimes to build models when you have such levels of disparity in your data. But maybe we could do that and start to see what the trends are and why these errors are occurring. You know, is it because of the tools and technologies, the frameworks, third-party code things that are present? Are they directly contributing to these? Maybe beyond just correlation, but actually starting to look at causation with these data. Also knowing where the successes are occurring. Are there certain patterns? Are there certain tools that really are resulting in better accessibility? And how can those be shifted and used elsewhere? And then we have a lot of bad models. We need good models, especially if we're going to start to use these types of tools like machine learning to accessibility. And then maybe even doing a little bit more of like automatically fixing, doing pull requests on repositories when these issues are detected. I saw this a few months ago. I thought it was kind of interesting. So on GitHub, there was a bot that detected a vulnerability in this particular dependency for this project on GitHub. So another bot got the first bot's results that identified the vulnerability and then sent a pull request to fix the dependency in this repository. Then a continuous integration bot verified that the pull request didn't fail regression tests, and then a different bot merged it. And when it was done, a different bot saw that this was a successful process and celebrated by posting this animated GIF to the thread with Simon Cowell giving the thumbs up. It was entirely automated, this entire process. And it was done entirely by computers, and it fixed what could potentially been a serious security issue via an entirely automated process. Pretty amazing. Why can't accessibility fixes happen in those types of ways? I think there's a lot of potential that we maybe aren't really utilizing yet to make these types of changes. As I look at the future, I think there are a few other things that we can and need to do. One is to transition from what are the issues, what went wrong and even what went right, to why did these things occur? Why are these errors continually introduced? Why have they not been fixed? Why, and what is it about particular models that are resulting in better accessibility that's causing them to be successful? So we need to get from the descriptive to the prescriptive, right? When issues are detected, or maybe even better, when issues are predicted, when we see the potential for an issue, how do we fix? How do we avoid those issues in maybe even more automated ways? And can we streamline that process? So especially in design and early development processes, so we're not going through this process of fixing the issues, but we're heading off those issues because we have good things that prescribe those fixes for us. And again, that's kind of the same idea of this last transition, that we need to see more from detection to prevention. And there are models out there, I think. There are clearly places where things are going well, or at least better. Government is one of those. Things are much, much better in government, the realms that you guys are working in. And I think that you have an opportunity, perhaps a responsibility, to start to take what you're doing and maybe expand that, bring it much broader to the web in general. I think that could be very impactful. Finally, just kind of on this thought of kind of machine learning and artificial intelligence. There's a game called Go. I'm not sure if you're familiar with it. It's was created in China well over 2,000 years ago. One of the oldest continuously played games. The object of the game is pretty simple. You have these stones on a board. The basic strategy is, if you surround your opponent's stones, his stones get taken off the board. But there are a lot of board combinations. In fact, there's 10 to the power of 170 possible board configurations. So there's more possibilities of the stones on this basic board than there are atoms in the universe. So this is a very, very simple game that is incredibly complex. It's kind of makes chess look like tic-tac-toe. And as they have looked at computer models to try to analyze and find solutions and make computers competitive in this game, this was kind of one of the final frontiers for artificial intelligence, is to be able to win this game. I mean, just to compute the next 8 possible moves, looking into the future of, if I make this move, what are the possible ramifications of that? It requires computing 512 quintillion possibilities just for eight moves into the future. So they started to tackle this with computers. AlphaGo had these AI models that were trying to do this, and they were never successful at beating this game until they started looking not only at the rules of how you win the game, but how humans perform in the game. As soon as they started plugging in the human models and understanding how humans would both succeed and fail in playing this game, where they would make the mistakes and where they wouldn't, that's when the computers finally started to learn how to beat this game. And now computers pretty much dominate this very complex game. So it's kind of exciting to me just to think the possibilities that maybe someday artificial intelligence can start to predict those human accessibility failures maybe better than even us humans do today. So I always end presentations when I talk about these data. It can be a little discouraging. I'll admit that. Sometimes it's hard to see where we're at with accessibility, but I always ask this question: what are you going to do about it? So that's my challenge to you. Think about what you can go out and do today, this week, this year, that can start to affect these changes for good, not only in the work that you do, but on the web in general. So with that, I will say thank you again. If I'll try to go back through the chat here a little bit, but if there are any other questions, please post those in the chat window. Okay, there's a comment there to find more information on the digital.gov communities of practice at the following link. Thank you. That's great. That's what we need, is good communities of practice like that for sharing. Sarah, oh, hi, Sarah. It's nice to see you here. Do you have specific things in mind in terms of how those of us in government can help others do better? Government's usual mode is passing laws, but that's a limited tool. Yeah, I agree. You know, the legal model absolutely is impactful. I in some ways shudder to think where we might be in terms of accessibility if we did not have legal requirements. But it is not always the most positive influencer for change. We have a thing on our website. It's called WebAIM's hierarchy for accessibility change. You can go look at it. That kind of outlines this hierarchy of what we have seen that results in the most influential change. And the law certainly is, but it's not most positive. What really is we have found to be most impactful is to make this real, to make it human, to demonstrate a web page in a screen reader, or better yet, have a blind user or a user with visual disabilities go through that site. And not only does it impact users, it impacts this user, this one sitting right in front of me. They're personally impacted. And when we did that kind of motivation and maybe inspiration to change that, that's what we found is most impactful. Those are the types of things I think that government can do. I think there's unique access to those type of users, that type of testing and resources in government maybe aren't available elsewhere. So that's a few ideas there. Did you do any tests with people with disabilities? Not as part of this research. We did not. This was entirely automated. We do testing with users with disabilities and other types of things. We have found in our manual testing that we do, when we also do automated testing, the same automated testing that was done via WAVE for this research, we do find strong correlations. In other words, the number of detectable errors corresponds with the non-automatically detectable issues that we collect via that human testing. So we know that there is a correspondence there, but no, we haven't done anything that wide scale. I kind of mentioned that briefly. I think that is a place for some potential with this, is to have better associations between the automatically detectable data and actual human testing data. And if we can better tie those in together, I think it'll give us a better sense of end user impact, but also we can maybe start to address issues that can maybe be detected not directly, but because of the presence of other types of accessibility issues. Hopefully that makes sense. That we can know that these human issues are present because these other types of issues are also present. I think there's potential for that. Is that happening now? I don't know. Probably not. We're not doing that, but I think it's potential for the future. There's a question. There are agencies good about web accessibility, but not so much on documents. Do you have any tips or resources for documents? Any recommendation on tools for correcting issues? Um, I don't. I'm going to do a little shameless self-plug here. WebAIM does have an online document accessibility course that's, I think, really great for, especially for authors, people that are creating content, to ensure that it's accessible. So you might check that out. We also have articles on Word, PowerPoint, PDF. We have quick references. So those are some tips and resources that might be helpful, specific for document accessibility, and recommendation on tools for correcting issues. There are some that are out there. The WebAIM site does have some documentation on some of the tools that are out there. We don't do a lot of PDF remediation ourselves. We focus more on the prevention part of that, the education, so that we don't have to fix so many issues. But there are some good tools out there. Ultimately, a lot of it, though, does happen and needs to happen in Acrobat Professional itself. That's where a good share of that remediation tends to happen. But there are some tools that can facilitate that. Okay, any other questions? I'll give it another minute here if there are any others that come through. And there's the comment there that the video will be posted to digital.gov in the coming weeks. I'm not seeing any come through. I'll just say thank you for the opportunity to present. Hopefully this has been helpful, and wish you just the very best in your accessibility efforts.